Okay, hi, this is Kelsey and Marshall. We are doing our CIT 260 method presentation, and we are going to start off with how to develop a method in 7 steps. We were given this outline, and it's been a really great tool to use. It helps us plan for eventualities, and this in regular Java classes, we've been just taught, hey, just start typing and hopefully it works and then figure it out. But this gives you a better way to do it in steps so you know that your code is going to work in the end. The first method is defining the problem. So you have to look at the problem just like you would any problem. Look at all the boundaries, the parameters, the conditions needed to make an algorithm and be able to write code for it. The next step is to create the test matrix. So we were given parameters for feed the people. And so, ask the user how many bushels of grain do you want to give the people? Enter a value, check to make sure the value is positive. So all these things are kind of given to us so we know all the boundaries and all the parameters that we need to move forward to write that code. The next is you outline the solution. So the first thing we did was we outlined all the parameters, all the conditions into kind of a small commented outline so we could use that when we went into NetBeans to write our code. And then we wrote a pseudocode right here, in public static int bushels for people in wheat and storage. And we kind of wrote what our code might look like in NetBeans when we wrote it in Java. And this gave us a good basis to go off of. The next thing we did is we had to test the algorithm. And so we had, what is valid? What's it gonna look like when it's valid? What's it gonna look like, when it's still valid, but the person doesn't have enough things to sell or buy? And then what are the invalid, tests that will come up with errors? And what are the boundaries? And so by doing that, we kind of give ourselves an idea of all of those things that we need. So when we write that code, it comes out clean and clear. So method five is to translate the algorithm into code. And so, we create a package, we imported, we create a class, and we started taking what we commented, in that gray area, and actually wrote code where it almost looks like a mathematical word problem. And so it just gives you these methods give you a real step-by-step basis so you can write your code successfully. And after you write that code, then you have to test it. You have to make sure it works. And NetBeans is really easy to test on, and you have to make sure that your test doesn't fail. And if it does fail, then you get to go back and fix those things. But it's a great way to test. You always want to test your code, because if you don't, you're not going to know if your program is working correctly. After everything's tested, everything's working, you commit it and you upload it to your Git or repository to share with other people or to put on your website. The next thing we're going to talk about is the explanation of the code, and Marshall's going to start with some code that he wrote.
So in this code, we were going to pay our tithing, basically where you take part of your wheat and you set as an offering. So basically what you want to take is the wheat that you currently have stored as a variable and subtract a certain percentage of it. So we took our 7 steps. We said, okay, we have these parameters. We want to make sure that you have enough wheat. If you don't have enough wheat, then we need to send an error message back to the user that says, okay, you don't have enough wheat, or whatever the case may be. So we set those boundaries in our test matrix, created some pseudocode, and basically says, okay, if you say, okay, I'm going to pay some tithing, but I want to pay less than 0 in tithing. Well, that's not really a mathematical possibility, so we return an error message there. If that offering is going to be over 100%, say you have 100 bushels of wheat and you want to pay over 100% in tithing, well, you can't give more in tithing than you actually have, so that's going to obviously be an error message as well. Or if your offering is less than 0, we're going to return that as an error. So what we want to do, also if you don't have any wheat to give at all, if you have wheat in store is equal to 0, error message. So basically what we want to take is whatever we want our tithing to be, We're going to multiply that by what our tithing percentage is, by what our wheat and store is, divided by 100 to get it back into an integer, and then subtract that. Your wheat and store is then going to be subtracted by what you paid in tithing. Return that back to your wheat and store, nice and clean and simple, with your comments in there so other people can understand your code as well. So then also with the crop control here.
This one's mine.
Oh, go ahead. Back to Kelsey. Sorry.
So I wrote this code, and like Marshall said, it's really similar to what Marshall just talked about. One of the things that we have written more if statements and not if else or if then, but just an explanation of like what those other statements can do. An if else statement it's a statement that, it's followed by an optional, the if else, it's followed by an optional else if that expression is false in the Boolean. The if then statement, which we haven't used yet in this program, it's a conditional statement. So if the hypothesis is true and the conclusion is false, then you get a different answer. And so like, a good example is, if I do well in school, I will get into a good college. If I don't do well in school, then I will not get into a good college. So that you have that then statement when it's necessary. On this part of the program, we're pulling in stuff from crop data. We're pulling in stuff from random because the price of land is randomly selected. And so we needed to pull in that random. And, we have like, if acres to sell is greater than acres owned, then you can't, sell anything if you don't have it. But then at the end, we subtract acres owned minus and the acres to sell. And also you have to buy land with wheat. So we have to determine how much wheat is in store. And so we had to put together a program, calculation for that. And it returns how many acres do you own after all of that. And Marshall is going to talk about lifespan of a variable.
So as we create these methods, each one of these methods and the variables within that method take up a certain amount of memory, and there are physical limitations on memory on a computer, obviously. So it's important to talk about the lifespan of the variables in there so that you can't just create a million variables because you're going to then bog down your computer and your memory and your program's not going to run right. So as you write your code, it's important to understand how these variables exist in memory so that you can keep your code as clean and as efficient as possible. So within this class, we do have the one method. We have the class of byland, and this method of byland has these local variables in it of acres to buy and wheat in store. So when this method runs, it's going to grab this information from where it needs to. It's going to create that information in local memory. It's going to make the calculations. It's going to return the calculation that you're asking for, and then it's going to release all those variables from local memory. So each one of these variables only exists within this particular method. So that comes as an advantage because then at that point it releases them from memory, which then gives you the flexibility that you can reuse that name elsewhere, which helps you kind of keep your code simplified when you're talking about similar variables. So that lifespan of that variable is only going to last as long as that method is running. And then once it runs, it returns, it's done. So in conjunction with that, in these parameters and the values in them, one of the powerful aspects that I'm figuring out with object-oriented programming is that these parameters can be called between methods and between classes. Whether they're public or private can play into that as well on where you can grab them. And so you'll notice the parameters that we call out in here. We create some local variables of land price, of acres to sell, but we also have our acres owned. So we can jump over to our crop data. We can get the acres of land that we owned based on this code right here. Use it as a parameter, and then we can go into once we do our calculations, then we can set the acres of owned and run it back over to that other class without having to pull all of that information over. So we can use those parameters in between classes for flexibility, and then we can get and set them as we needed, as we need to do within our methods. So that's kind of the rundown that we've completed here. It's been interesting. We look forward to kind of tying all the loops in together, and we thanks for your time, and there we go.